So this is a next lecture in the series. What we have discussed so far was about the different kinds of power plants. We classify them as steam-based, thermal, nuclear, and the wind-based, the solar-based, the gas-based, etc. And then we saw the power plant, the current power plant scenario in India, how like a large part of the power was being contributed by the coal power. Then there was a wind, then there was a solar, etc. And finally there was like the power plant economics. We saw the power plant economics, how the load factor was governing the amount of power demand, the load curves, the peak load, the power utilization factor, the plant capacity, etc. And based on all these factors, how and the total cost of the power plant, how it was possible to calculate the tariff rate. Then there was like the hydropower plant, the different kinds of turbines for the hydropower plant. And finally, next video is about the gas-based power plant. Already I have made a video about the thermal power plants, but before discussing the heat engine based or the heat based power plants, the steam turbine based or the gas based turbines based power plants, on which it is going to be acted by a hot fluid at a high pressure. So the hot fluid at a high pressure could be steam, it could be gas at high pressure. So this kind of power plants work on something known as thermal cycle or thermodynamic cycle. So thermodynamics is a large area, so if I would get any time to cover some videos about thermodynamics, and based on the response of the videos in this channel, I may make some videos about thermal cycle, thermodynamics, etc. So this is part of mechanical engineering. Even some of the thermodynamics is covered as part of the elementary schooling in the high schools like 11th 12th standard in India. Again, the thermodynamics is part of the basic mechanical engineering, which is a subject for most of the engineers, or a basic subject in the first year of most of the engineering students. So thermodynamic power cycle are basis for the operation of any of the heat engines. Also, this is the basis for operation of the steam-based generators and steam-based turbines. So the steam-based or the thermodynamics based or the thermal based power plants can be of two types. One is based on the vapor as a fluid which is being acting on the blades of the turbine at a high temperature and pressure. So this fluid could be steam. So if it is a steam, then it would be vapor based, and this could be based on the Rankine cycle, regenerative cycle, reheat cycle, or primary vapor cycle. So all these are the different vapor cycles. So you'll need specific lectures to cover about in detail about the different kinds of cycles. So if I will be ever preparing videos about thermodynamics, I will add them in the description of this video in future. So you could go through them. And again, there could be gas based. So the gas based cycle power plants are based on the Otto cycle, or it could be the diesel cycle. So these are the internal combustion engine cycles. So again, there could be the gas turbine cycle. So this is another cycle. So to demonstrate how this cycles works in a thermodynamical way and how you can derive the efficiency, I would take a simple example of the Rankine cycle. As you can see, there is a steam generator, and the steam is being generated at a high temperature. Also, the pressure is being increased in the generator. So it is whatever you are, so the steam generator would be a boiler. So the boiler would be having a combustion chamber. So in the combustion chamber, the fuel would be burned, and whenever the fuel would be burned, gases at high temperature and high pressure will be created. So you can use those gases directly, or what you can do is that you can use those gases to heat water. So whenever you are heating water, so inside the boiler you will be having tubes, and through those tubes water would be flowing, and when the gases at high temperature and high pressure would come in contact with the tubes of the boiler, it would heat this water to a higher temperature and pressure. So it would be converted from water liquid form to gaseous form, and it would be known as steam. So the steam generator would increase the temperature and pressure of the water. So the fluid which would be leaving out of the generator would be the steam at a high temperature and a high pressure, and what you are supplying is water at usually lower temperature than the outlet and a lower pressure than the outlet. So again, this steam or this gas at a high temperature and a high pressure would be hitting the turbine blades, and it would cause the conversion of the pressure energy or the mechanical energy. It will cause expansion on the turbine blades. So as it is expanding, that is a pressure is getting reduced as it is being acting upon the turbine blades. It will convert the mechanical energy to convert the mechanical energy or transfer the energy in the form of thermal energy which was there to, or the kinetic energy which was there, to the mechanical energy in the turbine. So work is being done by the turbine, and the turbine will rotate and it will be to the connected alternator or generator and will produce electricity. But again, the water which is leaving the turbine blades, so you will need to, it will be at a lower pressure or a lower temperature. So again, you will need to condense that. So there will be a condenser and it would be fed back to the steam generator. So that's how the full cycle works. And if you see the two graphs, then you can see that from A to B the pressure has increased. So what you have done is that pressure is increased. And if you see the temperature graph, again during that same time A to B you increase the temperature. So this is what is happening in the generator. So you increase the temperature and pressure, and again you are supplying that at C to the turbine blades, and there's an expansion happening. So the pressure is getting reduced as it is being acting over the turbine blades, as you can see in the graph, and then it is being cooled down and it is being transferred back to the steam generator again at a lower temperature. So again, this is how a Rankine cycle would work, and the efficiency is given at H1 minus H2. So H1 is the heat at the inlet of the turbine, and the heat at the outlet of the turbine blades is H2, and divided by H1, that is inlet, and HW2 is the condensed heat at exhaust. So again, this is how the efficiency can be calculated, and this was just a simple example of one of the methods of the to know the thermal cycle or the thermodynamic cycle. So again, this is a long series of lectures. So there's the next lecture is about the wind power plant, and after this I have lecture about the solar power plant. So those are the two power plants, and after this I may have a series of lecture, but you can find the full lecture about the power plant engineering in the description. And there is I will also prepare some lecture, not many lecture, but some lecture in the series of power system engineering. So if you want to know more about power system engineering, then the same lecture I will be uploading in the same playlist which you can find. So that will be some time later which I will be preparing, not immediately. So again, if you like this video, please do subscribe, like and comment.